Right. Hello, everyone, and welcome to the Tazama Connection Studio series. This is a solution which is designed to dynamically enhance financial message ingestion and transaction screening processes. This demonstration will cover how TCS enables quick onboarding of new message formats, automated data enrichment, and how it solves certain challenges in the world of financial transactions. So let's first have a look at the problem statement. So at the Zama, we face two main limitations. Each time a new message format, such as an ISO message or a custom payload, is introduced, it demands coding, testing, and development, which slows down the onboarding process. And secondly, data like sanctions lists, watch lists, and KYC information are scattered across various systems, which creates a delay in transaction evaluations and hinders the ability of the fraud analyst or of the Zama in general to investigate transactions with complete context. So this is where the Zama Connection Studio comes into play. What TCS offers is that new message formats can be configured, mapped, and validated without any coding required through TCS. This helps with rapid onboarding of new messages and supporting datasets such as sanctions lists are automatically pulled or pushed from external systems and are kept up to date through TCS, which ensures that every transaction is evaluated with the latest contextual data. All right, so now let's dive into a real world scenario where TCS can be applied. So let's say that Commercial Bank of Ethiopia currently uses ISO 222 messages, like PAX 8, for example. When payments fail, they often receive reversal information in an unstructured form, such as emails, PDFs, or manual notifications, which requires manual reconciliation. By using TCS and DEMS, they can quickly configure and monitor new message types like PAX 004, which is a payment return message. This essentially means that no coding or custom development would be required and that they can process the rejected payments in a structured ISO format, which makes the reconciliation process much easier. All right, now let's have a look at the architecture of the ZAM. So the process begins when a bank sends financial transactions into the system. And now these transactions are formatted as ISO 222 JSON messages, as I mentioned before, and they arrive in a sequence, sometimes as part of a larger payment journey. So as in pane 1, pane 13, PAX 8, and PAX 2. So these are the quote and reply. Uh, these are the quote and reply message, and then we have the actual payment transfer and then the confirmation of the payment. All right, so once received, the message enters the Tazama Dynamic Event Monitoring System, which we call the DEMS. And at this stage, the DEMS performs three key functions. It ingests the message, number one. DEMS captures the transaction and stores it in the system in real time so that it can be tracked and analyzed. And secondly, it transforms the message because ISO 222 messages can differ based on the message type. So DEMS standardizes the content of the message into a consistent internal Tazama structure. This ensures that all of the downstream components read and interpret the data in the same format. And then thirdly, it also enriches the message. So the data enrichment service collects additional information to support the evaluation of a message. Now, this may include pulling account history of a party or cross-referencing external data sets, for example, sanctions list, like I mentioned before, and risk scores of a customer. Now, by the time the message leaves DEMS, it is no longer just a raw payment instruction. It is complete, full of context data ready for monitoring. And once the ingestion and transformation is complete, the message is passed on to the event director, which acts as a decision point. It reviews the data it receives and determines whether the transaction needs to be monitored, which fraud or AML scenarios are relevant, and which rules need to run based on the configuration. So the event director then triggers those rules and sends the necessary data to the appropriate rule processors. Each rule processor then evaluates the transaction and any related historical activity against the design rules. Each rule produces a score and sends it to the typology processor. Now, the typology processor scores these results. Each rule contributes to a weighted value, and once all the required rule results for that typology are collected, they are summed into a final typology score. If the typology score reaches certain predefined threshold, a transaction is either interdicted or an alert is sent onward to the CMS, which is the case management system, for detailed investigation. Yeah, so this was pretty much the entire process flow and where DEMS fits into the Tazam architecture. All right, so before we move on to a system demonstration, let's have a quick refresher on the modules within TCS. So we have the TCS first, a configuration layer for defining message and enrichment data ingestion endpoints. And then we have the dynamic event monitoring service, which is the DEMS. This service is the one that dynamically validates, ingests, and transforms incoming messages, and this is on the execution layer in Tazama. So next we have the data enrichment API, which is again a service that pulls and pushes data into Tazama to enrich the incoming messages. Then I want to talk a little bit about the environments that we have. So there are two main environments that we'll be demonstrating today. One is the source, or which we're calling the dev environment. And this is where all of the configuration will be done, approved, and sent for approval. And the second one is the target environment, or which we can call UAT, where we will be exporting and deploying all of the configuration from the dev environment via an SFTP server. Okay, a little bit about the roles. There are four main roles involved in the end-to-end process of defining and deploying a new connection. Those are editor, approver, exporter, and publisher. So editor is the first role in the chain, the one who creates a new connection endpoint definition on the dev environment or the source environment and sends the configuration on to the approver, who reviews and approves the configuration. Once the configuration is approved, it is sent to the exporters bucket for them to place the configuration on the SFTP server. Then it is imported and deployed by the publisher on the UAT environment. So now that we have these terms sorted, let's move on to the actual demonstration. Below are the use cases we'll be presenting today. We'll go first with DEMS, since that is where the message ingestion occurs. And we'll show you how a new message connection is added via TCS and how an existing connection can be cloned to define a connection. Then we'll transition to how data enrichment endpoints are defined, both the pull and push kind, and how that data lands in our database. So yeah, that all will be covered in the next videos in the series. So see you there.